Hi, this is Natalie. So now we're exploring the sampling distribution of the sample proportion p hat. So this is a relative frequency distribution of various values of the sample proportion using a number of samples. Well, let X be the number of successes in n independent Bernoulli trials, with the probability of success is p. So we can see here X, it follows the binomial with the number of trials n and the proportion of successes p. So we can see, like we have already learned in the binomial distribution, that the mean equals to np and the variance of it equals to np times q. And the q is the probability of failure, which is 1 minus p. So now let p hat be the number of successes and divided by the sample size n, and let it be the sample proportion of successes. So let's explore the statistics of the sampling distribution of p hat. First, the mean, it's equals to p. And the variance, it equals to p times q divided by n. And the standard deviation is just the square root of the variance. And the standard error of the sample proportion is the same as the standard deviation. So let's see, let's move to the central limit theorem. When np is larger than 5 and n times q is larger than 5, which means n is sufficiently large, the normal distribution can approximate the binomial distribution. So it means by the central limit theorem, the sampling distribution of p hat is approximately follows the normal distribution with the mean of p and the variance of p times 1 minus p divided by n. And so let's see whether it can be standardized. So we do the standardization of the sample proportion. So z, it's equals to the p hat minus the mean, which is p, and divided by the standard deviation, which is the square root of p times q divided by n. And it approximately follows the normal distribution with the mean of 0 and the standard deviation of 1. So now let's use an example to illustrate that. Woolworths and Coles account for 80% of supermarket share. Suppose that a survey of 625 people were asked whether they shop at either Woolworths or Coles. What is the probability that more than 82% of the respondents will say that they shop at either Woolworths or Coles? So from the question, we can see that p equals to 80% and n, the sample size, it equals to 625. Let p hat be the sample proportion of people who shop at either Woolworths or Coles. So now we're trying to solve that the probability of the p hat is larger than 82%. So first, we have to think, can we use the normal distribution to approximate? Can we use the central limit theorem? So first, we have to check whether n is large enough. In this question, we can see np equals to 625 times 0.8, which is 500. And n times 1 minus p equals to 625 times 0.2. So it's 125. And we can see both of them are larger than 5. So therefore, n is large enough to invoke the central limit theorem. So by the central limit theorem, we can see that the p hat approximately follows the normal distribution with the mean of 0.8 and the variance, which is 0.8 times 0.2 divided by 625. So we can write this the probability into this way. We can standardize it. It's equals to the probability of Z larger than 1.25, and we should rewrite it into this way so that we can use the formula, which is 1 minus normal distribution, standard distribution, 1.25 in 2. So this is what we want.